Okay, today, guys, we are going to start in the last section of that chapter and the last section in our material in that quarter. So, in that quarter, inshallah, our exam will cover chapter 18 and chapter 19. So, that the last section of chapter 19 here, after we already studied stars and the life cycle of stars, then we studied the galaxies and so on. So, here, that's a very, very important question, okay, must come to our mind. How all that universe is formed, okay? So actually, this is a big question, and I think most of you may thought about the question before, and that's not easy question to be answered. The same happened to science from a long time ago. They always keep wondering how this universe is formed, okay, or what are the steps from long time ago, how the universe looked like, and so on. So that's push scientists to keep searching and just put hypotheses and test it, make experiments, okay, and try to collect data and so on. That lead to a formation of new kind of science, which is known as cosmology. So what is cosmology, guys? Cosmology, that is the science which study the origin, structure, and the future of the universe, okay? So again, here we have a new term, which is cosmology. So what is cosmology again? Who can tell me? Yes, Laura?
The study of the origin, properties, processes, and the evolution of the universe.
Oh, good. Okay, so the origin structure, the universe, and the future. You can say evolution, processes. Yes, all these. So whatever studying anything about the universe, okay, that's related to cosmology science. Yes, Otto.
No, I wanted to answer.
Okay, so here, guys, we said regarding to what we studied, we know that the universe is keep expanding. Yes or no?
Yes.
Who the first one who told that the universe is expanding? Who can tell me? Just raise your hand if you know the answer. Yes, Farah?
Hubble?
Yes, Hubble. Okay. How Hubble okay proved that the universe expanding? Do you know also?
Yes, by
Yes,
the Doppler effect.
Doppler effect. Okay.
The
Yes.
redshift.
Redshift. Good guys. We studied this before, and we know that the Doppler effect phenomenon or the Doppler effect feature, okay, figured out that because the light, okay, it's a or the apparent change in the light frequencies toward the red light means that the waves move farther away from each other. That means already galaxies are move apart from each other, which give a big or a good clue that the universe is expanding. To imagine, okay, or just to simplify the idea of the universal expansion, okay, we made a little experiment or a little model the science just put here. What would happen? Imagine that here, look with me, guys, that you get a piece of dough, you make a kind of dough, you want to make a cake or something like this. So you get a dough, and then you start to put some raisin, okay, and the dough. They all look like that, okay? So if you don't like raisin, you can put peanuts, whatever you want, okay? So here then we start to bake this dough. What would happen to this dough, guys? What do you think? Yes,
Larger.
Laura?
When you put it inside the oven,
Yeah.
it's going to expand.
Yes, it will expand. Actually, we're gonna find because of the fermentation and carbon dioxide it produced, so it will expand. And as it expands, if we just look to the distance between the raisin or peanuts, we're gonna find the distance between them. They just somehow increased. Whatever the peanut or the raisin that you are looking at, you're gonna find that the others are moving apart from each other due to the expansion of the dough. That's the same idea, or that's just kind of representation to what's happened in the universe. Scientists know that galaxies they look like okay this raisin okay which found in the dough while the dough represent the universe. So as the universe expand, the galaxies are move apart from each other and they go further and further, which give an idea that the universe is keep expanding, or call this the universal expansion. This example is clear, guys? Is it clear?
Yes.
Yep.
Yes, Mister.
So that's here lead to a very important question, okay? How the universe, okay, started, or that's didn't answer the question which we studied in the beginning of the session, which is how the universe started. As scientists, they're just seeing that the universe keep expanding and go away from each other. they start to think, okay, about the answer of the question, but they start to imagine anything that expand. It means it start as a small thing. Yes or no?
Yes.
Because we're already observing expanding, which means it was small, okay, from years ago, and the more years ago it was smaller and smaller. So they start to think in reversed way. They start to think backward. Okay, that means imagine that the universe is not expanding and moving, okay, in reverse way. That means the universe is shrinking, which means in the past the universe was small. So scientists start to hypothesize or put ideas about this, and they create a kind of theory we call the Big Bang theory. Okay, actually, Big Bang theory is considered the most famous and accepted, okay, theory to about the formation of the universe. Most people agree about it, but actually, we don't have any kind of evidence that 100% true ensure that the Big Bang has already happened. But we just have some hints and clues, maybe just evidences, okay, that somehow make us comfortable to this theory. So what they hypothesize, or what they assume in this theory, they assume that the universe would just kind of mirror. Okay, that means all the matter in the universe just was focused in one point. Okay, so that means they were under high pressure, temperature, and a lot of collisions happen between the particles of this matter, which lead to a massive explosions. Okay, so these explosions cause the Big Bang. Okay, or that means called the Great Explosion. So the particles or the matter of these explosions start to move farther from each other across the universe. You get the idea, guys? Is it clear?
Yes.
Yep. So here, that's how they already get, or how they put the idea of the Big Bang. Okay. So we said that the theory of the Big Bang, they assume that this kind of explosion, or this tremendous explosion, okay, is already done from about 13.7 billion years ago. That is the estimated age of the universe, okay, or how the universe is formed regarding to the information which science have. So actually, after they put this kind of hypothesis, or as they could put this kind of assumption, so should we agree with that kind of evidence or observation? What do you think, guys? That means if someone tell you that the Big Bang is true, so could you believe him without any evidence?
No.
No. So, like any science, we still need to have a kind of evidence or kind of proof or something that support the idea. Okay, so here actually we have something known as cosmic background radiation. What is cosmic background radiation, guys? So imagine with me here, guys, if you are the cake which we just made from, okay, certain time here. Suppose it's done. Let's check. Okay, so this cake, suppose you put it in oven, as Laura said. So as you put in oven, and then you open the oven to get this cake out. So and to keep the open door, or the sorry, the door of the oven open, what would happen? What you are gonna feel?
Heat.
Heat, good. So after a while, you're gonna find the heat energy, okay, is passing, okay, from the oven out to the kitchen. Yes or no?
Yes.
So as time passes, the kitchen air get warmer while the oven get cooler. Yes or no?
Yes.
And finally, the temperature overall the kitchen will be somehow equal. That means the temperature of the oven will equal the temperature of the air outside. But you're going to just feel a general heat, or that the air become warmer in the kitchen. Yes or no?
Yes.
So in that case, we describe, if we ask why the kitchen become warmer, you're gonna say because the heat, or the heat energy is radiated, or just that mean emitted and distributed all over the kitchen. Yes.
Yes.
So the same, actually, science observed something similar to that in the universe. What they observed, actually, there were two scientists. Okay, they already have their antenna. They receive different signals, or they just make a kind of researches. Okay, and they keep working on receiving different radiations from the universe. And actually, they find, okay, their antenna receive a certain radiations, but this radiation will have something different. What this, that this radiation coming from all the directions. So we are going to say what the problem. Already we know that the universe has radiation, or stars produce radiations and so on. Yep. Okay. Once science start to collect radiation from the universe, we collect radiation from a specific direction regarding to the position of the star or the planet or whatever. You get the idea, guys?
Yes.
But if you receive the same radiation, which means that safe wavelengths and frequency from all the directions, okay, that's something weird. It means there is no a certain position, or there is no a certain object that produces this radiation. You get idea?
Yes.
Is it clear for everyone, guys?
Yes.
Yes.
So that's which makes science keep wondering and asking, okay, from where we get this radiation. So they start to simplify the idea, the same like the example which I explained to you about the oven. So they start to think these radiations, they may be some radiations which already resulted from billions years ago from the Big Bang, and they still these radiations are distributing over the space to cover all these millions or billions of light years. Okay, so that long distance, okay, take a long time until we receive this radiation, or we keep receiving this radiation until this day. So they consider the cosmic background radiation as a kind of evidence for the Big Bang theory. Yes, Sama, you ask a question?
Mister, can you hear me?
Yes.
Can you hear me?
Yep.
I didn't understand the last part.
Yes. Okay, so one more time here, Sama. You understand the example of the oven and the cake?
Yes.
Yep. So what happened here? We said that in 1964, two scientists using a huge antenna. Antenna, that means it's just a device that collect a kind of radio or waves. Okay, radio waves or radiations. Okay.
Okay.
So what happens in that case? Okay, their antenna recorded a certain radiation that is already coming from all directions. Okay.
Okay.
So what's special about this radiation? Because, for example, as we said, we already make telescopes to receive radiation. So there is nothing new, Mister. I said no. Because once we use a telescope to collect radiation, we already receive a radiation from a specific direction regarding to the position of the star, the planet, the galaxy, whatever we collect the radiation from. Good idea? For example, when you are calling on me, okay, I detect your position regarding to the direct which I receive your sound. Yes?
Yes.
If I already, okay, so the same, if I observe a light like a flashlight, so I'm gonna just detect its position regarding to the direction that I receive this light from. But if you just hear a sound from all the directions, so can you detect its position, or that means there is a certain object produces the sound nearby you?
No.
No. So that the same happened to the science. As they keep receive the same radiation from all the directions, that means the same frequency and same wavelengths from all the directions, it means there is no specific object at certain position that produce this radiation, because if it's a certain object located at certain position, the wave's supposed to have a certain direction. So here, like this, that makes science keep asking from where do these radiations come, or what the source of these radiations. So scientists actually don't have a very accurate answer about this question, but they already assume that these radiations are already produced from billion years ago due to the Big Bang, and the same like the heat which is already distributed from the oven all over the kitchen. The radiations which already formed from the Big Bang, they keep distributed all over the space, but because the space or the universe is too huge, it take all this long time until we receive it in our antenna or receive it in our planet. Is it clear here, guys? Is it clear, Sama?
Yes. Yes.
Or
Yes.
do you understand that?
Yes.
Okay. So anyone can't understand this part again, guys? Guys, in her question regarding to this part?
No.
No.
Okay. So like this here, that the idea of cosmic radiations, and like that, okay, scientists somehow they believe in the Big Bang theory, or they thought, okay, that's the idea which could be accepted to explain how the universe is formed. Then we paused here to say the structure of the universe. So we ask the universe, this massive, okay, thing, or this massive creature, okay, which we just put very, very, very small part in. What is made up of? Actually, we are not able to know what all the universe is made up of, or what is the exactly structure of the universe, because it's too massive and we just put like a dot in that ocean, so lives, or a drop in that ocean, so we are not able, okay, to have a clear image about all the universe, how it look like, okay, or we cannot even receive radiation from the far distant parts in the universe, because due to these long distance radiations may be scattered or just distributed or just deflected, and we cannot receive that good even with the most developed technology that we have nowadays. But studying nearby objects in space and studying nearby galaxies, stars, planets, planetary systems, and so on, that gave an idea about how the universe look like, or how the universe, okay, is arranged, because we find there is something called a cosmic repetition. What being by cosmic repetition? We figured that the universe somehow have a kind of repeated units in which smaller objects always are part of larger structures or larger objects. For example, any planet, like you, the basic information do you have? The moon revolves or rotates around.
Earth.
The moon rotates around Earth. Okay, so different moons, they rotate around different
Planets.
planets. Okay, because as we know, the mass of the planet somehow is larger than the mass of the moon. So always the smaller mass rotates around larger mass. So like this, our moon rotates our planet Earth, and there is other planets that have moons. So our planet Earth rotates around
The sun.
the sun. So our planet is considered to be a part of larger structure, which is the solar system. Our solar system actually keep rotating around. Anyone know? Or rotates in? Our solar system is part of,
Milky Way.
yeah, Milky Way galaxy. So we are part of galaxy. That means the solar system is just part of galaxy, and different galaxies. Okay, they could be, or the many galaxies may gather together to make something good cluster. Okay, or galaxy cluster. So here, like this, that give hint about that the matter in the universe, they are not just scattered or just they are randomly distributed, but they have a kind of organization in which smaller objects always are part of larger things, and so on. So we're gonna find, we can say that the universe is made of clusters of galaxies. Each galaxy is made of many stars and planetary systems. Each planetary system is made of star and some planet. The planets already have moons rotates around them, and so on. You get these guys? Is it clear?
Yes.
Yep. So that's here how we could imagine, or how the universe look like, or that's how science they put an idea about how the universe look like. Then this side here we ask, how old is the universe? Anyone know? How old is the universe? Yes, Hanahani?
As the Big Bang theory said, it is the 13.7 years.
Yes, the estimated, good, okay, the estimated time actually, okay, for the regarding to the Big Bang theory, they said that the universe started to form from 13.7 years ago, okay, billion years ago, okay. So that's the estimated age of the universe. Anyone know what is the estimated age of the Earth? How old the Earth is? Do you remember, guys?
6 billion
Yes,
years.
Hannah Yasser?
7.6 billion years.
No, that's too much. Just a little bit, okay. So Laura?
4 billion years.
Yes, 4.6 billion years. Good. Okay. So here like this, okay, that's me, which means okay, already the Big Bang started, and that take a lot of billion years until they start to arrange and form our solar system. The question is, okay, how do we estimate these numbers, or how scientists estimate these numbers, how they could recognize it, okay? So there are different ways or different techniques to calculate. Of course, they are estimated numbers, not exact numbers, but they have their ways to calculate. What are the ways? They may, okay, they could estimate the age of the universe, okay, by measuring the distance from the Earth to the various galaxies, okay. What is the distance from our Earth to different galaxies, or the farthest galaxies we have? And as we know the rate of the expansion, that means how fast the galaxies move away from each other, we could predict, okay, so the time taken until they be in that position nowadays. So like this, we calculate it in opposite. For example, if I know that you are 10 meters away from me, and you just move about 1 meter each second, so it means the time that you started to move until you reach your position is about 10 seconds. You get the idea, guys?
Yes.
Yes.
So the same they do it with the galaxies or the stars. They start to calculate the distance between the Earth and these stars, and regarding we know the speed of these galaxies, how they are moved farther away from our galaxy. So we estimate how time does it take, or did it take, okay, until it become like that, okay, or in that position. That's one of the ways, okay. There is another way of also they could estimate by studying, okay, the age of the oldest star in the universe. As we keep searching for new stars, detecting new stars by using telescopes and so on. So the oldest star that we could find till that moment, okay, it may represent the age of the universe, because the universe or this old star, it means it's just started, okay, within the beginning of the universe. At least, okay, the age of universe will not be younger than the oldest star. You get the idea?
Yes.
Is it clear here, guys?
No, I'm still, I don't understand.
All the parts, that mean the distance and the age of star, or the just part of age of
Yes,
star?
yes, all.
All again. So here I'm gonna tell you. Look with me, Sama. I
Okay.
just need to know how is the time you take, okay, to be, okay, or I just need to know. So for example, you started to move from certain point, okay, to another point, okay. So I don't know how time, okay, or how much you keep walking, okay.
Okay.
So I need to estimate this time. So I said, if I find that the distance between this point, okay, which is A to the point B, it's about 10 meters, okay? Okay.
Okay.
Then I figured that you already moved, because I observed it, I observed your movement. I observed that you move 1 meter each second, okay? That means that's your speed, 1 meter per second, okay? So that means
Okay.
as already you reached point B and this started from point A, okay? So that means how many time already you took, okay, to reach point B?
10 seconds.
10 seconds, brilliant. Okay, so like this, I estimated the time you get, yes?
Yes.
So the idea, they apply the same idea to estimate the age of the universe. How? That's our planet Earth. So we start to measure the distance between our planets and the other galaxies, okay? And as we know, the rate or the speed in which galaxies are moving away from each other, we could estimate the time they took, okay? You got idea?
Okay. Yes.
That's the first way, or the first technique that they could use to estimate the age of the universe. Is it hard like this?
No.
No. The other way that we know, any star is more, okay, passed by different, okay, different stage in the life cycle. Okay, start to as a protostar, then start to be a main sequence, then red giant, and after it turned to be a dwarf star or something like that. Yes.
Yes.
And we could estimate the time that is used by these stages regarding to the nuclear reactions, which has already happened inside. Yes.
Yes.
So, like that, scientists said, okay, the age of the universe, okay, will not be younger or less than the age of the oldest star that they discovered. Yes or no?
Yes.
So if we estimated, okay, that's mean by calculation about the rate of nuclear fusion that happened in the star, we know the age of the oldest star, for example, it's about 12 billion years, okay? So that means, okay, of course, the universe will not be younger than 12 billion years. You get the idea?
Yes.
That's it. Any hard question here?
No.
So any hard question in that part, guys? Any hard question regarding to this part, guys?
No.
No.
So now we pass to the last part of our lesson here, okay? what gonna happen to the universe? What is the future of the universe? Because in the beginning of the session, we said that cosmology study the structure, okay, and the future of the universe. So what is the future universe? So of course, no one of us know what exactly will be the future of the universe, but we have sign of expectations, okay, based on the physical laws, okay, or the mathematical laws and formula which scientists use. So science actually have two hypotheses, okay, that as the universe keep expanding and moving apart from each other, stars, okay, is gonna keep getting older, and like this they will, their heat will cool down, and also, or their temperature will cool down, and they will start to lose their brightness and emitting the light. And in that case here we have two conditions. First one, maybe, okay, the universe is gonna have enough matter, enough material, okay, this matter will have, okay, regarding to this enough material, and no more nuclear reactions produce this enormous energy which keep the universe expanding and moving away from each other. Or it's still we have some energy, but it's not that much, okay, compared to the mass of the matter which found in the universe. So the mass of the matter will be too huge, so that will create a huge gravity, so the universe may keep collapsing or collecting each other and start to shrink. That means opposite, okay, circumstances or opposite of the Big Bang theory. Okay, is it clear here, guys?
Yes.
Yes.
The other hypothesis, which they said maybe after the stars already, or most stars, they lose their energy. The energy which is found considered to be enough for the amount of matter that found in space. That means there is no that heavy matters, okay, compared to the amount of energy which is left. So the universe will keep, okay, expanding forever. Okay.
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 So you heard question regarding to this part, guys?
No.
No.
So that's our lesson for today. I need you to just to, okay, study it well from your textbook. It's easy, okay, funny, and as you can see, like this, we in our material. So please study this lesson very well. Tomorrow, inshallah, we're gonna make kind of revision about it, discuss the hard points. If you find any hard point or question, just highlight it, okay, and we are gonna discuss it tomorrow, inshallah. So any question here, guys?
No, thanks.
Okay, don't forget to answer your section review. Okay. Any question before we end our meeting, guys? Or something's not clear you want to ask about it?
Mister, I answered this yesterday
I know,
and I said
I know. Okay. So any question here, guys?
No, thank you.
Thank you, guys. See you tomorrow. Goodbye.